Hi guys, Math 1513 College Algebra at Northern Oklahoma College. This is going to be a quick lesson on Chapter 6, Section 1 and Section 2. We're going to solve systems of linear equations in two variables. That's Section 1. And then Section 2, there's going to be three variables. So two variables, our solution is going to be simply an x and a y. Three variables, we're looking for a point with three coordinates, x, y, and z. We're kind of going three-dimensional here. All right, we're going to solve an equation in two variables by using substitution first. Substituting means if you know what y is, just put it in for y in the other equation and work and solve for x. So we find out x is -3. We already knew y equals 1, so we just write our answer as an ordered pair, -3, 1. All right, look at this set of equations. Before I substitute, I need to get y alone. And I see this y here is easy to isolate. So I move the 2x, I get -y equals -2x minus 13, and then of course that means y equals 2x plus 13. Since I know what y is now, I'll just plug it into the other equation for y and solve for x. And now that I've found x, I'll just use that x value of -7 and plug it into either equation and find out what my y is. So I found my y, and then I just write my ordered pair. And there's my answer. Here's an example for your homework problem number 13. Actually, I could go either way on this. Since I know what y is, I could plug it in for, whoops, that's supposed to be a y there, sorry. I could plug it in for y in the other equation, or since I know what x is, I could plug this in for x in the other equation. So just to go the other way around, I'm going to take this expression and plug it in for x in the other equation. And I get y equals 2/3. Now I just need to go back and find x. And using this second equation here, I get x equals -10/3. So just write my ordered pair. And the x coordinate is -10/3. So our solution lies 10/3 of a step to the left. That's like 3 1/3 steps left, and 2/3 steps up would be our solution. That's where the two lines are going to cross. All right, here's an example for your homework problem number 17. Now to use substitution, I have to isolate either the x or the y. Doesn't matter which one, I'm going to isolate this y right here. I'm going to get that y alone. All right, so I found out what y is in the second equation. So I'm going to take that expression and plug it back in for y in the first equation. That's what substitution is. Find out what your y is, plug it into the other equation. But look what happens. I get 9/2 is equal to 8. Well, that is not true. So if you come up with nonsense, a nonsensical equation, something that doesn't make sense, you know that this whole thing is false and that these two lines never cross. So since they never cross, there's no solution. And what kind of lines never cross? We're talking about parallel lines. So both those lines went up and over with the same slope. So since they're parallel, never cross, that's why we didn't come up with a solution. All right, we're still doing the same thing here. We're going to find out where these two lines cross, but we're going to use a different method. We're going to use elimination. Now, eliminate just means get rid of, so we're going to either make the x go away or make the y go away. Now, it doesn't matter which one you eliminate. I'm going to choose to eliminate the x. So I need to make the x's look the same, but one has to be negative. That way when I add them together, they'll cancel out. Now I'm going to refer to these as row 1 and row 2. That'll kind of prepare you for what's coming in the next section, solving in three variables. And I'm going to leave row 1 alone, but row 2 I'm going to multiply by -3 to change it to a -3x. So here's how I'm going to note that. Row 1 I'm just going to bring over. Row 2 I'm going to multiply by -3. I'll say -3 times row 2. And here's what I get. And when I add them together, the x's cancel out. That's my elimination. I eliminated the x's. I add my equations together, get 19y equals 19, which means that y must be 1. So I found my y coordinate. Now I just got to find x, and I can use either equation. So let's use our new y, and let's substitute it into one of those equations and find out what x is. I'm going to use the second equation. And I found my x of -3, so the last thing to do is just write the ordered pair where the two lines cross. So these two lines cross at the point -3, 1. All right, here's an example for your homework problem number 25. I'm going to call them row 1 and row 2 like I told you about. I'm going to eliminate the x's. You can eliminate the x's or the y's. I choose to eliminate the x's. So I'm looking at the x's and I'm going, what do they both go into? Well, 3 and 2 both go into 6. So I'm going to change the top to a -6 and I'm going to change the bottom to a +6. That way the x's will eliminate. And here's how I'm going to signify that. Row 1 times -2, row 2 times 3. That'll give me a -6x and a +6x. But remember, you have to do it to the whole row. So I found my y, it's 0. I just go back and substitute and figure out what x is. And remember, use in either equation. I'm going to use the top equation, row 1. And there we found it. And these two lines cross at the origin, 0, 0. Okay, on this one, an example for problem number 23, I noticed that 2 and 4 both go into 4, so I'm going to leave the 4x alone, and I'm going to change the 2x to -2x so that they cancel out. And I get 0 equals 3. Well, 0 does not equal 3. That's nonsense. And you can say your answer any number of ways. I like nonsense, but that just means this system is false. It has no solution. Again, we're talking about parallel lines that never cross. All right, moving on to 6.2, we have solving systems in 3 variables. So we have an x, y, and z. Now, visually, you might have to look at the book for a drawing of this or Google a representation of this. But I want you to imagine 3 sheets of paper. All right, each one is a plane. And these 3 planes are intersecting. And when all 3 pieces of paper or all 3 planes intersect, there's a single point in space at which these 3 planes will all have a common solution. So we're looking for that one point in space, that x, y, z coordinate, at which all 3 planes intersect. Now I've labeled my 3 equations, row 1, row 2, row 3. And what I'm going to do, I'm going to use the same method every time to solve these systems. All right, and that method is to eliminate the x's in row 2 and 3, and then also eliminate the y in row 3. That's my general method. What that leaves me is what's called triangular format. All right. Once I do that, that's going to allow me to go backwards through the equation and figure out what the x's and y's and z's are. You'll understand it in a minute. But the method is the same every time. Eliminate the x's in row 2 and 3, and then eliminate the y in row 3. So our method will be the same every time. I'm going to add row 1 and row 2 to eliminate x. I'm going to add row 2 and row 3 to eliminate x. Then I'm going to add those 2 new rows that we form, row 4 and row 5, to eliminate y. And after I've done all that, I'm just going to go backwards and substitute. It's called back substituting to figure out what my x and y and z are. So you might want to write a little note here. This is the method we're going to use every time. All right, so let's add row 1 and row 2. I want the x's to go away, so I need row 2 to be a -2x. So I'm going to leave row 1 alone, and I'm going to multiply row 2 by -2. And I get this expression, which I'm going to call row 4. That's our new row. Now to add row 2 and row 3 and make the x's go away, I need that x in row 2 to be a -4x. So I'm multiplying row 2 by -4. All right, -4 row 2. I'm going to leave row 3 alone and just bring it over. And I have this expression, which I'm going to call row 5. Now I'm going to add row 4 and row 5 to eliminate y, but something you need to recognize is that all of these guys are divisible by 7. So you always want to look for little tricks like that to make your life easier. Let's simplify row 5 by dividing everybody by 7. And I have -2y minus z equals 6 is my simplified row 5. Okay, I want to eliminate y. 11 and 2 both go into 22. I need to make sure that one is a -22 and one is a +22. So what I'm going to do is I'm going to multiply the top by 2. That'll give me my -22y, and the bottom by -11. That'll give me a +22y. And I solve and get z equals -2. Hey, that's one of my 3 coordinates. Remember, we're looking for an x, a y, and a z. I just found z. We got to go back and find y, and then go back and find x. That's back substitution. We're working backwards through the problem to find x and y. And I find my y is -2. Now the last thing is go back to one of our 3 original equations, row 1, row 2, or row 3, whatever looks easier. Notice on this one here, I picked row 5 for my substitution just because it looked easier. It would have worked in row 4 too. Go back to row 1, 2, or 3, pick out whichever one looks easier, put in your y, put in your z, and figure out what x is. I used equation or row 2 because it looked easier, put in my x and y, or I'm sorry, my y and z. Now let's figure out what x is. And x equals 1. The last thing to do is write your answer as an ordered pair. And there we have it. Those three planes intersect at this one point, 1, -2, -2. All right, let's try this example for number 11. Where do these three planes intersect? Remember, add row 1 and 2 to eliminate x. Add row 2 and 3 to eliminate x. Let's start with that. Row 1 and 2, the x's both go into 15. So I'm going to multiply the top times -5 and the bottom times +3, or row 2 times +3. That'll make my 15s cancel out. And I get my row 4, but remember, always look for a way to simplify it. Now these are all divisible by 2, so I'm going to simplify it by cutting everybody in half, and that'll be my row 4. Now I said to add row 2 and row 3 to eliminate x. The important thing is to eliminate x from row 3. So I'm going to show you that you can use row 1 or row 2. The important thing is on the first step, eliminate x from row 2. The second step, eliminate x from row 3. Now the x's in row 1 and row 3 both go into 12. So I'm going to multiply row 1 by -4 and multiply row 3 by +3. That'll give me opposite 12s that'll cancel. And I get this. Now remember, that's going to be our row 5, but let's simplify it first. I notice they're all divisible by 7, so I'm going to divide them all by 7, and that will be my row 5. So I multiply row 5 by 11 so that my y's cancel out. Solve, and I get z equals 0. Now let's just go backwards and find y and then find x. Now remember, you can use almost any equation. I'm going to use this one right here to find y. It just looks easier to me. And that gives me y equals 3. Now let's go back to one of our original, row 1 or row 2 or row 3, and find x. I'm going to use row 1. It looks easier to me. And I find 3x equals 0 and x equals 0. Write your ordered triple. That's 0, 3, 0. Okay, so to adjust the instructions a little bit, we can also do it this way. We can add row 1 and row 2, and then row 1 and row 3. Both purposes are to eliminate x from row 2 and row 3. Then add row 4 and row 5, our two newly created rows, to eliminate y. And then just go backwards and substitute in. You'll have your z, go back and find your y, then go back and find your x. Use row 4 or 5 to find y, and use any of your original row 1, 2, or 3 to find x. All right, here's an example for 13. Row 1 and row 2, the x's will go into 12. So I make one a -12 and one a +12. That way my x's cancel out. Remember to simplify. So this is actually my row 4. And on my x's on row 1 and row 3, they both go into 33. So I make one -33 and one +33. That makes the x's cancel out. Remember to simplify. So there's my row 5. Now I just add rows 4 and rows 5 to make the y eliminate. Uh-oh, look what happened. All right, I was trying to find my z and everything eliminated out. But look at my situation here. 0 equals 0. That's not nonsense. That's a true statement. 0 does equal 0. So what does this mean? This means that there's a million solutions. There's a million numbers that work. Your three planes are going to meet in a line, and there's a million dots on that line that'll work. So it all just kind of depends on what z is. So we're just going to call our z z. We're not going to give it a number, and just express y and x in terms of z. So I use equation 4 or 5, and I plug in, I just solve for y. I get the y alone. And I get this expression here. So here's our answer so far. We know the z is just z. We know the y in terms of z would be 4 minus z over 2. Now let's just go back and find the x. There's my substitution. Now I'm going to multiply everything by 2 just to get rid of that fraction. And I solve and get x equals -z over 2. So there's our answer. The book uses c instead of z, but I like z better.